Okay, first of all, here's a wee revision of index laws and indices. So if you remember back, base is the A and the index is the N. So base A to the N raises it to a power, okay, or an exponent, where N is also the exponent. Anything to the power of 0 always equals 1, all right? So when you see the index as 0. And if you have a minus power, that is just 1 over the positive version of that power. And we'll see how that works in a minute. I think we have covered that. So for example, if you see 10 to the negative 2, that just means 1 over 10 squared, and that is 1/100th to 0.01. That should make some sense to you, because if you actually put that into your calculator, find the key, you will find it does give you 0.01. Okay, so negative powers are negative place values, or smaller place values than place value 1. Compared that to 10 squared, which is 100, not 1/100th is when the power is actually negative. All right, so that one there is just a comparison. So I'll just put a wee little bracket around it, not to confuse anybody. Okay, so looking at the index laws here that were listed, we have actually done these at the start of the year. If we have the same base but 2 different powers and we're multiplying those numbers, we can just add the powers. The division law allows you to subtract the powers when you are dividing a common base, indices of the common base. This one here, when you have brackets or expansions, you multiply the 2 powers, and if you are expanding an entire bracket, you raise a to the m, which is a power m, and you also raise m to the b. So it's a little bit like expanding that bracket. And the last wee rule here is the quotient. So the same thing, it's in a bracket, but you have a rational expression here, a fraction. And so the m is powered to the a and to the b. So we can take the brackets out and use the index on each of those bases. So what I'm going to do next for you is we're just going to have a look at the examples in the book. So if we do the first one together here, 3 to the power of 0 is always 1. Okay, so that's looking back through the idea here of powers. Next thing, this one here is 5 to the power of 5 by 5 to the power of negative 3. So we simply add those powers. So 5 and negative 3 is the same as 5 take 3, which is 5 squared. That's our answer for that one. So that particular rule there that we're using is the multiplication index, the first rule. Okay, part C, or example C, we have this term here, 10, I think that looks like 0. I'm actually going to just blow that up. Yep, 10, 0 multiplied by 10 to the negative 2 over 10 to the 3. So here we have a combination of multiplication and division going on with the base 10 number. So we simply can, let me just blow that up a little more. I think that's a 9. So sorry about that. We're simply going to add the 2 powers that are on top, and we can then take away the bottom power, all right, and the bottom of it. So the minus 2 kind of ends up going downstairs as well. So 9 minus 2 is 7. And then we can subtract the other power, 3, so that will leave us 10 to the 4. Okay, last one in the first set. We have the product law going on here. So it's just a simple example of this one here, which is in a bracket. So we simply go 3 to the power of 2 by 3, 6. Okay, let's look at the second examples, second sets. Now, back to the top. If we have, and I've actually hammered this one a little bit for you, so if we have a minus, a negative index, then it's 1 over the positive version, or it's the fractional index. So in the case of this one, that would be 1 over 2 to the positive 4. Now it says evaluate here, not simplify. Actually, simplify and evaluate means you find the final answer. So let's just come back to the top. The answer is 1. 5 to the power of 2 should be 25. So I'm just going back and doing the evaluate parts because I've realized I haven't done it. The third one, we had 10 to the 4, which is 1 with 4 zeros. So I've evaluated that. 3 to the 6. Just going to stop the video. Okay, I'm going to start the video. I know 3 squared is 9. So we have 3 squared times 3 squared times 3 squared, which I'm really just rewriting that one. So that would be 9 times 9 times 9. 9 nines are 81 times 9. I'll let you finish that off. And let's come back now to example 2 because we realized it just says evaluate, but we had to simplify it first. So let's evaluate that. And 1 over 2 to the 4. 2 to the 4 is 16. So we've done enough there. We'll just leave it at that one there. Part B, 1 over 5 to the negative 2. Now the good thing with these ones here, it's already downstairs in the denominator. We're just going to flip it back up. So in a way, what we're doing is we're positivizing it like that. Okay, so with that one there, that becomes 25. Okay, so we're taking the reciprocal once again. So it is downstairs with a negative power. We flip it and change the power to a positive, which becomes this one here. Okay, which is 25. Okay, let's do the next one. C is 3/4 to the power of negative 2. With this one here, we can actually do it a couple of ways. First of all, I'm just going to flip it over and change the power to a positive power. And then I'm going to apply, so I've applied this expression here, this rule, and then I'm going to apply the power of a quotient index law. So I'm going to then make it 4 squared over 3 squared, which is 16 over 9. I don't think I can simplify that any further, and it's okay as a fraction. Okay, so a nice tidy fraction, which is in its simplest form, is a good enough answer. And the last one here is this figure here. Not sure what they're meaning by this one. Let me just have a little think about that one. Okay, so this last one, you can actually just straight evaluate it in your calculator. Remembering bed mass is BED. Now the E is your exponents, which is your powers. So what you need to do is you're doing 300 by 0.8 to the power of 6, or raised by 6. You actually need to do this first. So if you just enter that in your calculator and make sure you do power 6 first before you times by 300, you should get your answer.